Welcome to Sukma View. This is the series of engineering mechanics. We'll cover whole engineering mechanics in this series of video. This is the introduction lecture. So let's start. So before starting, we should see the classification of this subject. So engineering mechanics can be classified into two types. See, what is this? This is the solid mechanics and the fluid mechanics. And further, solid mechanics can be classified into two types, that is, deformable body mechanics and the rigid body mechanics. Further, rigid body mechanics can be classified into two types, that is, statics and dynamics. Further, dynamics can be classified into two types, that is, kinetics and kinematics. Okay, so this is the classification. See, what is the actual subject? So, what is mechanics? What is mechanics? It's a branch of physics. Physics include light, sound, all these concepts are included in physics. This is a part of physics. Okay. In this mechanics part, what we are going to deal? We are actually going to deal with force. Broadly, I'm speaking, we are going to deal with force and its effect. Whatever effect will be produced due to the application of this force. Okay, this is the mechanics. In engineering, what engineering we are going to deal? In engineering, there are different branch of engineering, like electrical engineering, electronics engineering. Okay, so engineering is means something we are going to build, or we are going to design, or we are going to invent. Okay, so in engineering, we are actually discussing this engineering mechanics on the aspect of design engineering. Okay, so the mechanics, whenever studied on a solid object, when you are studying the concept of mechanics, that's called solid mechanics. Whenever you are studying the concept of mechanics on a fluid, that's known as fluid mechanics. The solid mechanics is of two types, that is the deformable body mechanics, and the other one is rigid body mechanics. Okay, so what is this? This rigid body mechanics. Okay, so solid. Look, if I'll draw an object, this is the solid. There are two types of force. This is the surface. Okay, any surface you assume. There are two types of force. One force is normal force, and the other one is tangential force. Okay, so this is known as normal force. This is known as tangential force or shear force. So the classification of solid and fluid, an object, if you are applying what? You are applying shear force. That means along the surface, what will happen? The object is going to deform. Okay, this is the object initially. It will deform like this. Okay, what will happen after the removal of this force? The object will regain. It will try to regain its shape. Okay, whatever the shape was initially, it will try to regain that shape. In case of fluid, what is happening? If this is the surface over which liquid is present, okay, or gas, two things, liquid and solid, are the object which are in the category of fluid. In this fluid, if you are applying what amount of any amount of shear force, what will happen? This is the elements, that means I'm talking about fluid elements. Okay, these are the elements was initial like this. Under the action of this shear force, this fluid element will go like this. Okay, it will travel. So fluid at time t1, the elements, whatever element, the first element 1 2 3, it will go like this 1 2 3. After another time t2, it will reach here. Okay, so it will what will happen in case of fluid? If you are applying any shear force, you will get continuous deformation. You will get continuous deformation under the action of what? Under the action of shear force. Any amount of shear force. That means it will not resist. No resistance to the shear. Okay. No resistance to shear force. This is the force. Whenever we are studying this concept of mechanics on this fluid, there is a specific subject which is very important in mechanical engineering and chemical engineering or civil engineering, that is known as fluid mechanics. This is a important subject. Okay. What will happen in case of solid? Solid will try to regain. Okay. So it is trying to regain its shape. Regain its shape. Why it's trying to regain? Because of it is resisting that shear force. Okay, the force we are applying, why? Our aim is to deform, but the solid is regaining its shape. Why? Because it has the potential to regain its shape. That means it is resisting our application of force. Okay, so this is the difference between a solid and fluid. Getting my point? So this is the actual difference between a solid object and a fluid. In case of fluid, you got liquid and gas, but in fluid mechanics we are actually dealing with largely on fluid. What is deformable body and rigid body? See, this is the deformable body. You got deformation, actual, the real body. Okay, this is the real body, a real object. What is rigid body? This is the ideal body. Why I'm saying ideal body? There is, in this whole universe, there is no object which is actually rigid. The definition of rigid body is saying you take any random shape object. Okay, any random shape object, and you consider 2 point. Okay, you consider 2 point. The distance between these two, the distance between these 2 point is not going to change under the action of any amount of force you apply. The force F1, F2, F3, whatever magnitude amount. Okay, what may be the direction of the force, but the distance is not going to change. This is the rigid body. So definition of rigid body is simply saying you consider any object if the distance between any 2 point on that object is not changing under the action of any amount of force is known as the rigid body. So this is an idealization. Okay, in the universe there is no ideal body, there is no actual body. Okay, so rigid body mechanics, this is the subject we are going to deal. That means all the concept we are, the concept of mechanics we are here in this subject, we are this is the idealization that we are applying on rigid body, or we are studying rigid body mechanics. Okay, then the rigid body mechanics or the engineering mechanics, this is the classification. That means statics and dynamics. Okay, statics and dynamics. What I'm saying, statics is the part of engineering mechanics or rigid body mechanics in which the object is at rest. The object is at rest. That means the object is not moving on a horizontal surface or in an inclined surface. Okay, so this is the, in this the amount of force is applying like this is the force here, also for weight acting, force acting, all these things are, we are only dealing with what? Static part. That means in the statics part we will talk about what? The object is at rest. Object at rest. That means we will talk about only the equilibrium. Okay, only will study the force, there is no motion. In dynamics there is motion. Okay, motion is happening, the object is moving. Again, if, why any object will move? Because of the application of force. Again, if the force is studied, here we will not consider force, In kinetics part, we will consider force. That means what I'm saying. See, dynamics is the classification of engineering mechanics or part of engineering mechanics in which the object is in motion. In this motion part, this is further classified into two types: kinematics and kinetics. In the kinematics part, we will talk about displacement, velocity, acceleration, all these things we will study without considering force. That means we are not concerned about the cause. We don't know about the cause of motion, how the motion is being produced. Okay, in kinetics, we will talk about force and motion. Okay, motion study along with along the force. Here only we will talk about what? Only we will study about motion. We will not consider anything about the cause of motion. So this is the broad classification of this subject. Okay, what we studied: mechanics, the concept is, that means the force and its effect on any object. Then we talk about the difference between solid and fluid. Solid will try to regain its shape whenever the force is removed, the shear force is removed. But fluid is a substance which will continuously deform under the action of shear force. There will be no resistance to the shear force. Liquid and gas are the two objects which are coming in the category of fluid. Okay, this is the subject known as fluid mechanics. And here solid mechanics can be classified into this real body object or real object mechanics, that is known as strength of material. Okay, this subject is known as strength of material or mass, that is mechanics of solid. These are the name of the subject, same thing. Okay, then this is the subject we are going to deal, rigid body mechanics. Okay, so let's get into the other aspect of this. So see, what is it? What is engineering mechanics or rigid body mechanics? Okay, so I'm writing on idealization. What is the idealization or assumption? The object is whatever object we are going to deal, that is the rigid body. Okay, this is the idealization we have considered in this whole subject. So what is science? See, what is applied science? What is engineering mechanics? These are the three things we will discuss. See, science means whatever in the universe, in the real world, whatever we are seeing or observing. Okay, the phenomena, whatever phenomena is happening surrounding us, that observation is known as science. Okay, the heavy object is falling from an higher altitude to low altitude. Okay, water is flowing, the heat is transferring from a hot body to a cold body. Okay, T1 to T2. Okay, so like this, these are the concept of science. That means the natural occurring phenomena we are observing, and then we are applying this concept of universe. Okay, to make something. That means we are applying this concept, that's known as applied science. Okay, again this applied science is a branch of what? Is a branch of science. Again, applied science can be classified, have different classification. So one part is engineering mechanics. Okay, there are different classification of applied science. One of these is engineering mechanics. Okay, so in applied science there are very large, like light and electrical engineering, the concept of quantum physics, all these things we are seeing. Okay, so this is the engineering mechanics. Actually this is the fundamental to the design subject. Okay, fundamental to the design engineering. So engineering mechanics is very much useful in the higher subject. Okay, this is the base of engineering. It will be applicable for mechanical engineer. It is useful for civil engineer. It is applicable to any structural engineer. Okay, anything which is coming under design, we'll talk about engineering mechanics. Okay, so why to study this subject? See, look at this bridge. This is the bridge. There are different, look, the design of this bridge, the design, which is made of what? Made up of steel. Okay, any material, any mechanical material. Okay, it is made up of steel or iron, whatever you say, any material. Before designing, we should look on two things. What is that? That is the strength and stiffness. The strength and stiffness. That means whenever a train will pass through this bridge, okay, when a train will pass through this bridge, what will happen? The bridge will vibrate, and due to the load of train, it should have sufficient strength, else it will deform like this. Okay, so the bridge will deform like this. So the bridge should have sufficient strength and sufficient stiffness. The strength is the resistance to the external load, and stiffness is the resistance to the deformation. This is the deformation what is happening due to the applied load. Okay, so the bridge should sufficiently designed on the criteria of strength and stiffness. Okay, so that it can withstand the external load what is applying. Again, look at this water tank. This is placed at a high altitude from the ground. Okay, there is component. Look, whatever the, like this, these are the steel rod and steel pole, whatever element, like it is like a bridge, it should also have these two things, strength and stiffness. Else what will happen? If it can carry a load of 50 newton and you are applying 60 newton, what will happen? It will fail. This pole will fail. Then what will happen? The structure will collapse. So it should have sufficient strength. Okay, again, look at this vehicle. Each component of this vehicle, okay, what will happen? It is subjected to external load and it will undergo deformation. See, are you looking? There are suspension like what? Suspension, you are applying any load, it is getting deformed. So if the suspension does not have sufficient strength and stiffness, what will happen? It will deform or it will break. So what will happen? The vehicle will get into accident. Okay, so any design in the real world is based on strength and stiffness. See, this is the cantilever beam. In our any home, we are seeing an over the window there is a cantilever beam. That means one part is fixed, other end is free. If you are applying any load on this, so what will happen? There will be an resistance. The material should have resistance over here so that it can resist the load. Else what will happen? It will break. Okay, so any design we are seeing in the actual world, it should have sufficient strength and stiffness. These are the two things before designing anything. So designing anything, you should look at two things, that is strength and stiffness. Strength is the property of any material to withstand the external load, and stiffness is the property of material to withstand the external deformation. Okay, so how to study this engineering mechanics? See, we'll first go through some fundamentals like units which will be used in this whole engineering mechanics. Then we'll talk about trigonometry and some calculus and vectors. Okay, these are the four things we should look at the content. We'll talk about initially force. What is force? What is the classification of force? What are the effect of force? Then we will talk about moment. What is moment? What is couple? Then we will talk about equilibrium of an object, how an object is at rest. Then we will talk about center of gravity. What is center of gravity? Then we will talk about moment of inertia. Then we will talk about friction, then application of friction, then truss and frames, then virtual work concept. Then we'll talk about lifting machine, and then in the dynamics part we'll talk about rectilinear translation, curvilinear translation, projectile motion, rotation of the object, rolling motion, laws of motion, collision, work power energy theorem, pendulums, and any other anything remain. So this is the most fundamental, that is we'll start from the fundamental, then we'll go like this: force, moment, couple, equilibrium, all these concept we will cover one by one. Okay, so have patience, we will understand. Thank you for watching. We'll meet in the upcoming video. Thank you. So before that, look, these are the two things in many examination. This is exceptional. Okay, you just look at the syllabus of your examination for which you are preparing. Okay, else mostly topic will be covered. So thank you.